Hello everyone, in this video we're going to learn about geometric probability. First we're going to talk about the probability and the length. Now we have the line segment AD contains the line segment BC. Now we have the point S right here. Now we need to calculate the probability for the point S land on the line segment BC. So we need to calculate the line segment BC and the line segment AD. And we take the line segment BC divided by the line segment AD. So we have the probability of the point S lands on the line segment BC. Now let's take a look at the first example right here. Using segments to find the probability. Point K on ST right here. So point K somewhere on ST is chosen at random. What is the probability that point K lies on QR? Alright, so you know that QR, the distance between Q and R right here is going to be 3 units. Alright, so probability for the point K lands on the line segment QR is going to be equal to QR divided by ST. Alright, QR is going to be 3 units. ST is going to be 12 units. And the answer must be 1/4 or 25%. Let's move on to example number 2. A commuter train runs every 25 minutes. So we draw a line segment 25 minutes. Alright, so point A right here, point B right here. This is 0, 5, 10, 15, 20, and 25. If a commuter arrives at the station at a random time, what is the probability that the commuter will have to wait at least 10 minutes? Alright, so if a commuter will have to wait at least 10 minutes, which means commuter will go to the gas station between 0 and 15 minutes, sometimes right here. Alright, so probability at least 10 minutes is going to be equal to 15 over 25. Alright, so you're going to simplify, divide the top and bottom by 5. It's going to be 3 over 5 or 60%. Alright, second one, probability and error. So you have the quadrilateral R and the triangle N right here. Now, I have the point S right here. Alright, I need to calculate the probability so that the point S lands on the triangle N right here. So in order to do this, I need to calculate the error of the triangle. I divide by the error of the rectangle and I get the probability. Alright, so let's move on to the example number 3. A circle is inscribed in a square. Point Q in the square is chosen at random. What is the probability that Q lies in the shaded region? So point Q should be somewhere else right here. Alright. Now you need to calculate the error of the shaded region. In order to calculate the error of the shaded region, you need to calculate the error of the square, subtract the error of the circle, and then you get the error of the shaded region. Alright, so I need to calculate the error of the square first. It's going to be equal 6 square. It's going to be 36 square. Now, the error of the circle, because this guy 6, and then the center should be right here. And the radius must be equal 3. Alright, so the area of the circle equals pi r squared. Alright, so it's going to be r equal 3, so it could be 9 pi. Now, the area of the shaded region is going to be 36 minus 9 pi. Alright, now the probability for point Q lands on the shaded region. It's going to be equal to 36 minus 9 pi divided by 36. Alright, and bring up the calculator. You have 36 minus 9 times pi equal to 7.7. And you take this one, you divide by 36. And it could be 0.21. Alright, so it could be 0.21 or 21%. Now let's move on to example number 4. An archery target has 5 color scoring zones formed by concentric circles. The target diameter is 122 centimeters. So this is the whole circle right here. This is the target. Alright, so the diameter is 122. You need to calculate the radius. So the radius of this guy should be 122 divided by 2. And you get 61 centimeter. Alright, the radius of the yellow zone is 12.2 centimeters. So the distance from here to here is going to be 12.2. Now, the width of each of the other zones is also 12.2. So the distance from here to here is going to be 12.2. If an arrow hits the target at a random point, what is the probability that it hits the red zone? So you need to calculate the area of the red zone. In order to calculate the area of the red zone, you need to calculate the area of the whole circle right here. Subtract the area of the yellow one right here. Alright, so the area of the whole circle right here is going to be equal to pi r squared, where the radius equals 12.2 from the yellow one plus the width right here 12.2. Alright, so I have the radius. Alright, the radius of this, radius of the big circle equals 12.2 plus 12.2. It's going to be 24.4 centimeter. Alright, so we have the area of this guy. It's going to be area of big circle. It's going to be pi r squared. So pi times 24.4 square. Now the area of the yellow is going to be pi times 12.2 square. Alright, now you need to calculate the area of the red one. So you subtract area of the red equals this guy, subtract this guy. So you have pi 24.4 square minus pi times 12.2 square. Alright, now you need to calculate the probability. Alright, you need to calculate the area of the target. So the target had the radius, it's going to be 61 centimeter right here, which is the entire circle right here. It's going to be equals, it's going to be equal to pi times 61 square. Now probability that it hits the red zone, right? So red zone is gonna be a red right here. Divide by a target right here. Alright, so you just substitute the value pi times 24.4 square minus pi times 12.2 square over pi times 61 square. Right, for this one, I just factor pi out and I cancel pi right here. And I'm going to end up with 24.4 square minus 12.2 square divided by 61 square. Alright, so I have 24.4 square minus 12.2 square equals divided by 61 square, and it's going to be 0.12, so it's going to be 0.12 or 12%, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.